Hello everyone, welcome to lecture number 6 on multiple integration. In this lecture, we are going to discuss about triple integration. The main learning objective is the student will know how to solve triple integration. In last lecture, we already discussed about double integration. We have given the function in two dimensions, that is x and y, and we solve this integral with respect x and y. Here function is in the form of x, y, z. It means in the three-dimension function, and we have given limit here x1 equals to f1 y comma z and up to x2 y f of y comma z. It means the limit of x in the form of y and z, or maybe constant. Similarly, we have given the limit of y in the form of phi1 of z to phi2 of z. Either this limit is given in the form of z or constant. And last limit is z1 equals to a to b. Here z is constant, and here we take the limit of z is constant. For that we get the last, we integrate the constant limit, so we get the last answer is constant value. Either we have given the y is constant and z in the form of x, so then we integrate first with respect to z and then the constant limit, that is with respect to y. Here we take the one example. Solve this integral. The limit is 0 to 1, second is x square to 1 and 0 to 1 minus x. Function is 6z dx dy dz. Here function is given 6z and limit is 0 to 1 minus y. Either this limit is for x or z. If we consider this limit is for x, if 0 to 1 minus y, then this limit is for y and last limit is for z. But it is not possible we take the limit 0 to 1 minus y for y, because y is not equals to y 1 minus y. So here the limit is only for either x or z. If we consider this limit is for z, then this limit is for y and last limit is for x. With this we have take this limit is for z, that is z from 0 to 1 minus y, and y is for y x square to 1, and last limit is x equals to 0 to 1. We one by one integrate. First we integrate with respect to z. We get the answer, that is 6x square by 2, and put upper limit minus of lower limit, that is 3 in bracket 1 minus y bracket square. And then we integrate with respect to y. Here we get the integration, put again upper limit minus of lower limit, and lastly we integrate with respect to x and put the limit for x, that is 1 to 0, that is 0 to 1, upper limit is 1, lower limit is 0. We get the final answer, that is 16 by 25. Similarly, here the second example, that is 0 to 3, minus 1 to 2 and 0 to 1. And function is x, y, z square. Here all three limits are constant. We have to decide which limit is for x, y, z. In the last lecture we already see the same type of example in two dimension, that is in double integration. Here how to decide this limit. Yes, dx is inside the function, so the limit for x is 0 to 1, that is inside integral is for dx, and for middle one, that is y, the middle integral is for y, that is minus 1 to 2 is limit for y, and last is dz, so outer limit integral is for z, that is z running from 0 to 3. And we integrate this function. Here all three are in multiplication, so we integrate differently in multiplication form, or we can integrate one by one. Here we integrate first with respect to x, and at the time of integrating with respect to x, keeping y and z constant. So here we integrate x, so we get x square by 2 and y and z square as it is. Put upper limit minus of lower limit in x, because we integrate with respect to x. Similarly, we integrate with respect to y. Again at time of integrating with respect to y, z square by 2 is constant as it is. Here z square by 2 is constant as it is, and integration of y is y square by 2. That's why we get here 4. Again put upper limit minus of lower limit in y, and then lastly we integrate with respect to z and put upper limit minus of lower limit in z, so we get final answer, that is 27 by 4. This is our final value of this given problem. Here the examples we can solve this. Thank you.